So we're going to look at special right triangles, and we're going to develop what we know about 45, 45, 90 triangles in this video. So let's get right into this first triangle. First triangle made up of this square. So one thing we know about squares is all of their angles are 90 degrees. Okay. So with that, I know that C is going to be a 90-degree angle right off the bat. The other thing I know, and I can get there a couple different ways, if we go back to our quadrilaterals lessons, um, I know that with a square, the diagonals cut the opposite angles uh, evenly, congruently. So I know that A and B are going to be congruent. I also know here that because these two sides are both congruent, then these opposite angles are going to be congruent. And one way I can figure out how, if I don't know off the top of my head, if I need to work on this through this logically, if I know that angle A plus angle B plus angle C equals 180, and I know that angle C equals 90 degrees, okay, I can subtract this out. So angle A plus angle B equals 90 degrees. And because I know angle A and angle B are congruent, I can just divide this by 2. So angle A equals angle B, which equals 45 degrees. Okay, that's the long way to go about something that I already know. So I'm not going to dive too much further into that because I should already know this. But given this type of triangle, what we see here, we have a 45, 45, 90 triangle. Now, in order to figure out our missing side, okay, because I know side A is 1, side B is 1, I need to find side C, okay? In order to solve for this, I need to use Pythagorean theorem to start right now. So we can always use Pythagorean theorem with a right triangle. Let's use it right here. We've got 1 squared plus 1 squared equals C squared. This is my C, okay? So 1 squared is going to be 1. We're still equaling C squared. To get C by itself here, okay, I need to take the square root. So I'm going to end up with the square root of 2 equals C, okay? And this is kind of the same as 1 square root 2, okay? Anytime we have just a square root 2, we can have an understood 1 there. We're going to keep that there for the future, okay? Angle measures, we know that we're going to use the same angle measures for all three of these. So we are dealing with 45, 45, 90 triangles, and I'll go on ahead and mark that on my next one as well. Okay, so our side measures, they give us 2 and 2. So let's use Pythagorean theorem. 2 squared plus 2 squared equals C squared, because I'm solving for C. Okay, 2 squared is 4 plus 4 equals C squared. I end up with needing to find, and I'll go on ahead and use red there, the square root of 8 to equal C, all right? And if I use the birthday cake method that we've used in the past, we have 8. I'm going to divide by my lowest number that I can, so 2. That's going to give us 4. Divided by 2 is 2. Divided by 2 is 1. And now I've got my birthday candle on top. And I have a pair of 2's, so that can come outside of my square root. I've got a 2 left on the inside, equaling C. So I've got 2 root 2. Over here, I've got 3 squared plus 3 squared equals C squared. 9 plus 9 equals C squared. I'm going to take the square root of this, whatever it ends up being. So it's going to be 18 square root equals C. I do my birthday cake method. So 18 divided by 2 equals 9. Divided by 3 equals 3. Divided by 3 equals 1. And I have a pair of 3's. I'm left with a 2 inside. but I can pull that 3 outside, and that's what C is going to equal. So if I'm paying attention, 3 root 2, I had 3 and 3. If I look at all of these, we can develop a pattern, which is actually going to be our rule, okay? A is 1, B is 1, C is 1 root 2. A is 2, B is 2, C is 2 root 2. A is 3, B is 3, C is 3 root 2. So essentially, if whatever my side is, okay, whatever my short leg is, so for A and B, all I'm going to do is add a root 2 to find the hypotenuse. We have another rule that we'll see on the next slide. In order to work backwards if we're given the hypotenuse. But when we're given a number as a side length, all we've got to do is multiply that by root 2. We would actually divide by root 2 to work backwards. So that is developing the rules that we're going to be using. And so for the next couple videos and the next couple slides, we're actually going to apply the rules that we just developed.